to talk about is not worth extra credit this semester. So it's not very related to this class at all, but it is, I think, really a hot topic right now because the price of cryptocurrencies is high again. So I put it in my 141 class. At the bottom of my webpage, samsclass.info, this is the page for next semester's cryptography class, and I'm adding a lot of cryptography projects to it because these books are both free. This Mastering Bitcoin book is a few years old, and the Mastering Ethereum book is now free for everyone. It sold for commercial for about a year, and then he made it free. And based on that book, I'm going through here and writing Ethereum projects, and it's going very well. So you won't get credit this semester for doing these projects if you care about City College credit, but I made it into a CTF. There's commit flags and have a scoreboard so you can see how you're doing. These are all my old cryptography projects that cover the usual stuff like RSA and AES and all that stuff, which is the main cryptography, but I'm adding a lot of blockchain stuff to it. And I've got the first 6 of the blockchain projects up, 5 or 6 of them so far. So I'm focusing primarily on Ethereum. This book is wonderful. It is very clear, but it is a couple of years out of date. So the exact instructions here don't work quite the way you should, but he covers a lot. So I've been through the first 3 chapters here, and I turned that into 5 or 6 projects. And then we're going to go deeper and hopefully get it down to smart contract security. That's where I really want to be, where you write smart contracts in Solidity and then you find the security defects. And I found a few other tutorials about it. That's, I think, what would really suit us best. But you do have to learn how to use Solidity. So here's some projects to get you started, and this is growing very rapidly. I'm getting these at the rate of 1 or 2 per day. So there will be a lot of these. So for example, just to get started, if you just want to use Ethereum, then you just need a wallet. So MetaMask is one of the most famous common wallets. It's just a Chrome extension. So you put on the MetaMask extension, and they warn you to be careful to get the one that really has a lot of users because people make fake MetaMask extensions. And the Chrome store is pretty famous for being pretty sloppy and letting malicious people in the store. So if they can trick you into using the wrong MetaMask extension, then they can steal your cryptocurrency. Now, all my projects, I assume you're going to use fake cryptocurrency. It's not worth any money. If you're really investing in cryptocurrency, then you should be careful what you do. It's very easy to get swindled and lose your money in a variety of ways. But all we're doing here is learning how it works. I'm not talking about investing. I'm talking about understanding the technology. That is my goal. So you put on MetaMask, then you just create a wallet. It will show you this backup phrase, which is about 12 words, and you have to save that somewhere. And if it was really a wallet you were putting in real cryptocurrency, you'd have to really save that somewhere where it can't get stolen. If you lose that, you're going to lose your cryptocurrency. If somebody else gets it, they're going to steal your cryptocurrency. In our case, we're only going to use fake money. Now, right now, MetaMask is connected to the Ethereum mainnet, which means you have 0 Ethereum, and if you wanted some, you'd have to pay money, and I think it's thousands of bucks per Ethereum now. You'd have to pay some money to buy some, and then the price would go up and down, and then you'd be in the gambling game of Ethereum. But I don't want that. There are several test nets put up just for people to develop software, so you switch to the Ropstein test network. And if you do that, you're using fake Ethereum on a network that is designed to be the same as the real Ethereum network, so you can test software. There are several of these. And I liked the Ropstein because in case you care about the carbon footprint of cryptocurrencies, the Ropstein network is not proof of work. It does not have thousands of high-powered machines wasting tons of electricity to run it. It's proof of authority. There's a small number of machines that are chosen to mine it that do not have to win some difficult race to mine it because nobody else is allowed to do it. So it works the same way as Visa and MasterCard, with a trusted central authority. So it is, in fact, inexpensive to run and not as harmful to the world. So I figure I might as well use that one. So that's the Ropstein network. And now there's a request. You can just go to a faucet and request Ether. It didn't work too well. When I tried it, I got one. Then when I tried to get more, it wouldn't let me get any for a few hours, saying it was busy. And then I just tried again the next day and got a couple. So you might have trouble. But if you try for a while, you'll get some Ether. And so after a while, I had 1 Ether on the fake network. And now you can send your Ether around. So in the project, I just have you send me some Ether, 0.01 Ether. The faucet will give you 1. And if you can't get 1, you can contact me and I can send you some Ether. I've got a couple of wallets with a few Rothstein Ether in it. I can send you some fraction of an Ether. And then you can send me the money. I tried to send 0.001 and it won't go. There is a transaction price to send money, and I don't think you can send an extremely small amount of money. There's not enough to pay for what they call the gas. So 0.01 Ether seemed to be a convenient low number to send. And so you can see the activity of sending an Ether to me, and that gives you a flag. So this is the bare bones of how to use it as a customer, where you can get your Ether and spend it. And then you can see the block explorer. Like Bitcoin, the Ethereum blockchain is a public structure. Everybody in the world can see everything you're doing. They can't see your name, though. They just see your account numbers, which are these long hexadecimal numbers. But anyway, if you go in here, you can see there's a diagonal arrow here when you view details of a transaction that will let you view it on the public blockchain in Etherscan, which is one of the public blockchain explorers for the Ethereum. So anybody can go on Etherscan and view the blockchain, and they can see your transaction, but all they see is a from address, a to address, and the quantity and the fee. So this is why there's a company called Chainalysis that services the government and law enforcement and other people tracking these transactions and figure out who these people are, and helping them track down people who send things to the Bitcoin or Ethereum or other chains on the internet. And that's why Zcash exists. Zcash makes great efforts to anonymize these transactions by randomizing all the contract numbers, so it's very hard to track things down. Let me get it. Chainalysis. Yeah, there it is. Chainalysis, that is the company, I'll put it in the chat, that tries to track people down on the blockchain. And they claim to be very good at it, used by FBI and law enforcement and other people. And the whole point of Zcash, which I might as well put here too, it's the anonymous blockchain, which is supposed to resist that, be very, very, very privacy protecting. So these are the two companies in sort of opposition, like a virus and an antivirus company. Supposedly, if you use Zcash, Chainalysis still can't find you. I don't really know who's winning in that battle, but that's the idea. And there are other privacy-enhanced cryptocurrencies out there too, and there are other chain analysis companies. So it's just like everything. There's the cops and the robbers battling over trying to de-anonymize this anonymous exchange. Anyway, so that's the start here. And by the way, I forgot my seed phrase, and you can recover your seed phrase. So as long as you remember the password you had when you made your account, you can recover your seed phrase. All right. By the way, if you were to lose your seed phrase, then you would lose any real money you had in there. And this has happened to a lot of people. I think something like 10% of all the Bitcoin that was ever mined has been lost. And can I do these projects as a summer project? You can certainly do them. I don't know if they're going to be, feel free to do them and you get credit in 141. I don't know if they'll count as much of a research project because it's all kind of written up. But if you find some way to go beyond them, then that would make a great project. So start with these and then find some way to extend them. That's what I would do. That would make a good research project. And there's so many other things to do. There's other blockchains. There's one thing I'd like to do is get inside the code of MetaMask. MetaMask is public. The code is public. So sure, these ones as themselves aren't enough to make an interesting summer project, but some kind of extension would be great. Anyway, then you can make a Solidity contract. This is a smart contract that runs on the Ethereum blockchain, which is why it's better than Bitcoin. So yeah, good. Anyway, so yeah, you use this thing called Remix, which lets you construct contracts right in your browser. So when you go here, it'll start with a few default contracts, and you can make a new one. And this is what a faucet looks like the faucet you use to get some ether from on that test net. This is all you do, just a version of this thing. This is the name of the contract, faucet. This will just accept any money that anybody sends in. That's all it does. Receive any kind of money, funds that come in, any ether that comes in. And if anybody asks for ether, it will just send them whatever they asked for, as long as it's not too big. That's it. That's the entire Solidity contract to make a faucet. So you enter the code, you compile it with this button. That will compile it from this language called Solidity into the actual binary language that goes on the blockchain. And that looks like assembly code here. And it turns into bytes. That's what's actually going to be written on the blockchain. And then you have to deploy it. So you compile it locally, then to deploy it, you run it here, and that costs you gas because you have to write onto the blockchain. Yes, this is being recorded. Don't worry about it. It'll be up there. Anyway, so you deploy it onto the blockchain. And by the way, someplace back here, you made sure you're running on a test chain. I don't remember where I put it, but someplace you do specify the chain. Yeah, someplace up here. When you deploy it, I think. Yeah, here when you deploy it, you choose the environment. And if you choose Injected Web 3, it will go to MetaMask. And MetaMask is connected to the test chain because otherwise it would cost you real money to deploy it. You'd have to have real Ether and you'd have to pay a fee. Every time you use the real Ethereum blockchain, you have to pay a fee to do that. And that's true of all blockchains. Here we're also going to pay a fee, but we're paying in fake money. So anyway, that's why when you deploy it, it's going to pop up a box from MetaMask and ask you to confirm this is really going to spend some of your Ether. So you do that. That's going to deploy the contract. And then you can go here and search your account, and you'll see the contract now has an account. It's a new object on the blockchain, and it has no money, but it has a transaction which deployed the contract creation. So you have a faucet, but the faucet is not going to work because it doesn't have any money to hand out. So you have to send it some money. So you just, it has a contract, it has an address just like anybody else. So you just send it some money. Some of whatever you have. I sent mine, I guess, 0.3 Ether. I didn't have very much. I only had 1 because I was having trouble getting Ether from the other faucet. So I sent 0.3 Ether into it. Now you'll see 2 transactions on the blockchain, creating the contract and then transferring in 0.3 Ether. So now the contract has 0.3 Ether, so now you can withdraw some Ether from it. So you put in a number. The number is in these ridiculous things called Wei, which are 10 to the minus 18 Ether. So this is, I think, 0.1 Ether, which is a ridiculously long number. That's the way it works. And not only that, because of like a JavaScript limitation or something, I saw an explanation, you have to put this number in quotes. I remember I figured that out years ago when I made a project about hacking PWH coin, and it was quite a surprise. You have to put in an integer value in quotes or it won't work. Anyway, so you put it in here and withdraw, and then you can withdraw from it. And you'll see now there are 3 transactions. You created it, you put in 0.3 Ether, and then you withdrew money. But notice the amount you withdrew was 0 Ether because for some reason the original request, when you sent a request up to the contract saying, give me some money, that was not a transfer of Ether. So that had 0. It was a secondary activity, which you'll find on the tab here called Internal Transactions. The reply to that sent money back. So on the internal transactions, that's where you'll see the 0.2 Ether, the 0.1 Ether move around. Yeah, someplace in here is the 0.1 Ether. There it is. So anyway, there you get to see the simplest possible contract, a faucet, what it looks like, how you deploy it, and how you use it. And on it goes. Then you can make a node. These ones take a while. This is where you make one of the servers that runs the net. And so here I made a node on the Kovan proof of authority testnet. If this one's proof of authority, maybe that one we're using there was not proof of authority. I'm not quite sure. Anyway, this one is using the proof of authority. You need a Linux machine. You need a lot of space. It took about 30 or 40 gigabytes to store the net. And it takes a long time to sync. It took me on like 19 hours. So this is a drag. You can use different software. The 2 pieces of software used to run Ethereum nodes are Parity and Geth. Parity is based on Rust, which I was very excited about because Rust is very secure and I've got some Rust projects. And so I wrote this using Parity, and then I found out that Parity has abandoned it about a year ago. So it still exists, but it's no longer recommended. People say you should use Geth. For the next project I used Geth, so you can see them both. So you can use Snap to install Parity on a Debian-based machine. Snap is a strange installer intended for portable devices, but it works. The only thing weird about it is you have to always write the data in certain folders. Snap is not allowed to write data anywhere. but you just start parity on the Kovan testnet, and that will just launch it, and it will then spend hours processing the blockchain, downloading it, and preparing your machine. And when you're, and you can interact with it with the remote procedure calls. So in another window, you can just send curl commands to the local host on 8545. You can make requests of the blockchain server, and you put them here. Your method goes here. This is the activity client version, and here's where you put parameters, and there are no parameters in this one. So if you send that curl, it will tell you the version you're running. And I'm running a Rust-based parity with this particular version. And you can watch the syncing process. If you call the ETH syncing request, it will show you the current block is 127, the highest block is 17A. So it's got a ways to go. And then if I wait a minute or so and try again, then my 127E has gone to 127F, so it's gone up by about 1,000 in hexadecimal, and the highest block has only gone up by 4, because Ethereum mines a new block every 15 seconds. So if you wait a minute, there are 4 new blocks. And so my machine is processing 1,000 per second, and the chain is growing at 4 per second, so I will eventually catch up, but it took many hours. And so you can view the recent blocks, and you see this is what a block of the blockchain looks like in its raw structure. You have a difficulty number, and typically the difficulty number changes frequently to adjust for all the miners to make it take 15 seconds for someone to win the lottery that's happening. But in this case, the difficulty number is always this strange value with a whole bunch of Fs and ending in FE, because this is a proof of authority blockchain. Like I said, the difficulty stays very low and it never changes, because it's not like it's hard to do the calculation. It's just only certain machines are authorized to do the calculation, which is how normal companies work. You don't make it any more difficult than you have to. You just don't let anybody do it unless they're a trusted machine. And then you have the hash of the parent block in every block. That's what makes the blockchain a chain. Each new block contains a hash of the previous block, so it can verify the data. And then you have transactions. Here's a container of transactions, and there can be a different number of transactions in each block. So here's the block hash of that one, and there's the block hash of the next one. So this transaction happened to contain, this block happened to contain 2 transactions. And that's what that block looks like. Some are bigger, some are smaller. So you can look at a few blocks, and here's a current block you can look at to get a flag. And then you can see the syncing status, and when your syncing finishes, you'll find another flag, but that'll be 19 hours later or longer. And it had to download 50 gigabytes to do that. So that's what's going on the server. And you can make a private Ethereum blockchain, which is much easier. Now that one was synchronizing with a public blockchain that's been growing for years. The blockchains just grow and grow, and they never stop. So they just get bigger and bigger. But you can make your own private Ethereum blockchain by I did it with Geth. You could do it with that other product too, but Geth is the standard. So you install Geth, and then you make a configuration file which just specifies how to start your blockchain. We're just full of like boilerplate values, and then you launch your blockchain, sending to that data directory, and then you init this with that initialization file, init.json, and this tells it where to store the data. So it will now prepare your thing. This will take a couple hours anyway, just to prepare the cryptography. It has to go through a long process of preparing. No, not this one. Yeah, I thought it had to spend a couple hours to get ready. I've forgotten. But anyway, this just creates the Genesis state. That's right. Now you have to create an account, which you can do. You get a public address of your local blockchain key, and now you start. Okay. This is what happens. Now you want to start your node running, and you want to start it mining. So it'll process the blocks, and this takes hours to set up because it has to set up some complicated cryptographic object called the DAG, which I don't really understand, but it does take a long time. So this is the command to do it that will start mining and have a few other parameters, and it will also start listening on RPC for more commands. So it runs, counting up a percentage, and then it counts it up again, and then it pauses for like 30 minutes with no message. And after a couple hours, when it's done with all this preparation, then it starts mining and shows you the picture of a mining hammer here. So now it's actually a functioning blockchain processing blocks, and now you can do accounts and stuff. But the main thing, of course, is now you're going to have some money. If you look at your the accounts, there's only one account in the blockchain, the one you created. And now if you look at your balance is going to be a number now. Remember, this looks like a big number, but it's probably a small number because it would have to have 18 digits to add up to an ether. But now, because you're mining, you're earning reward for every block you mine. And so you're getting some money now. And after this, you could create another account and send money back and forth. And I haven't done all that yet, but we're headed there. And so then I made the mobile wallet on a Android emulator. There's a mobile wallet in MetaMask, and you can connect it to these test chains. You can also connect it to your private blockchain. So, we're off to the road here, and there'll be a lot more of these. But I wanted to show you those. I highly encourage you to start getting used to playing with Ethereum. There's going to be a lot of jobs. Cryptocurrencies are coming, like it or not. And it will be a good thing on your resume if you are somewhat experienced at setting up cryptocurrencies, understanding contracts. But for God's sake, don't invest a lot of money in them. Anyway, that's what I wanted to show you.